In this section, we're going to talk about factoring, and really the rest of the unit we will be discussing factoring. The first type of factoring is being able to factor out the GCF. And reminder, the GCF stands for greatest common factor. So a greatest common factor is a number that you can evenly divide out of a group of terms without having any sort of remainder. Okay, so what I mean by that is, let's say we had the number 10 and the number 18. So what's the largest number that can be divided out of 10 and 18? So if I think about, like, a 2 goes into both, right? Now a 5 will go into 10 but not 18. A 3 goes into 18 but not 10. So that's kind of the idea you want to go through. So on these first examples, I'm going to list out all of the factors and then identify the greatest. And then the idea is eventually you won't need to list every single number out. Okay, but I'm going to go real slow here to begin with. All right, find the GCF, greatest common factor, and then we're going to factor each polynomial. All right, so I'm going to start with 30. So I'm going to make a note for 30. So I'm just going to write out all the factors of 30 starting with 1. So 1 times 30, 2 goes into 30 15 times, so 2 times 15. And feel free to use your calculator to divide this out. 3 also goes into 30, 3 times 10. 4 does not, 5 does as well. Now, see how I'm close to 5 and 6 are real close together? There's no more distinct factors. I'm going to leave a little bit of space, and then I'm going to list out the 25. So factors of 25 are 1 times 25 and 5 times 5. All right, so what I want you to see here is I want you to identify the largest number that is contained in both numbers. So when I go to look at this, I see that 5 is in 25. And do you see how 5 is also a factor of 30? So like if I were looking at 25 here, I would ignore that because there's no 25 on this side. I can't use 10 because 10 is contained here but not over here. Okay, so 5 is going to be the GCF with respect to the numbers. But we also have variables. Okay, so I'm going to list out m squared over here, and then I have m over here. Well, if I expand out m squared, that means there's 2 of them, right? If I look at m, there's just 1. So there, between the 2, the greatest common factor is just 1 of the m's. All right, so here's kind of what I'm thinking. Over to the side, I'm going to make a note here that my GCF is a 5 and an m. So I can divide a 5 and an m. That is the most that I can divide out of my expression. So I'm going to set my problem up like this. So you're doing the opposite of distributing. You're not multiplying in, you're dividing 5m out. So I'm going to say to myself, if I have 5m, let's do the numbers and then the letters. Take the original 30 and I divide by 5, I'm left with 6. Take m squared, and I divided 1 of them out. There's 1 more left. Now check yourself real quick. If I re-multiply here, I should match the problem. So that's going to be 30m squared. Okay, so that looks good. All right, now I have minus. 25 divided by 5 is 5. I had 1m. I put it out in front, so there's nothing more to add here. Now check, re-multiply. 5 and 5 is 25, and then there's your m. So this is my factored answer, 5m times 6m minus 5. Okay, so all we're doing is identifying the GCF, dividing it out into the front of the parentheses, and then we're writing down what's left. So I'm going to do a couple more examples where I write all of this out. Eventually you're going to get to the point where you're just going to think through the values and then kind of make a decision on what the GCF is. All right, so I'm going to make my list here. Okay, 49, I have 1 and 49, and then 7 and 7 are really the only other factors. I'm going to go ahead and go in order here, n to the third. So there are 3 of them. 1, 2, 3. Okay. And so I'm going to kind of separate out. My next grouping would be 14n squared. So 14 would be 1 and 14, 2 and 7. N squared, there's just 2 of them, so I'll just write both out. And then lastly, I've got, I'm just going to do these from the positive perspective. I have 7, and then I have n. So 7 is just 1 times 7, and then of course, if it's just n, there's just 1 of them. All right, so I'm going to circle the largest factor that's a number between all 3 pieces. So I'm looking at the numbers, the 49, the 14, and the 7. So I'm really going to start with the 7. So I have a 7 that all 3 terms have in common. So if I wanted to list out my GCF, 7, and then what about variables? Well, there's 1 here. I can take 1 out of here and 1 out of here. So 7n would be my GCF. All right, so I'm going to set that up in front of parentheses. So now I need to divide 7n out of all 3 terms. 49 divided by 7 is 7. N to the 3rd, and I put 1 out in front. There's 2 left. And again, remultiply. 7 and 7 is 49, n and n squared is n to the 3rd. Then I have plus, so 14 divided by 7 is 2. N squared divided by n, there's only 1 left in parentheses. And then minus 1, because I have 7. 7 divided by 7 is 1, n divided by n is 1. And recheck, remultiply here. So 7n times negative 1 gets me back to negative 7n here. And that is your factored answer. Okay? So, like I said earlier, I'm wanting you to get to where you don't have to write all of these out. But if it helps you to write them out, go right ahead. The goal is that you find the GCF. That's the point here. Okay. I'd like you to pause the video and do 3 and 4 on your own. So do 3 and 4, and when you get to a point where you're done, come on back to the video. Okay, the first one, the largest number I could divide out, it was a 1. So in a way, we say there is no GCF between the 3 and the 8 as far as numbers go. But I could divide a y out. So I just have the y in front, and then what's left is 3y minus 8 in parentheses. So I guess if you wanted to write the GCF, is just the letter y. Okay, on this one, so I've got, so 6 would be 1 and 6, 2 and 3. And then for y, I've got 3 of them. And then for 3y, let me separate that out. So 1 and 3, and then just a y. And lastly, we've got 12. So 1 and 12, 2 and 6, 3 and 4. Okay, I usually start here with the fewest amount of factors. So between 1 and 3, do I have a 3 in the other groups? I do. So that means that 3 is the biggest number. Now look at the y's. There are no y's over here. So I can't divide a y out in front because all 3 terms don't have it. So my GCF is just the number 3. So I'm going to have 3, and then I'm just going to divide 3 out of all 3 original terms. So 6 divided by 3 is 2. So all the variables stay. 2y to the third minus y, because 3 divided by 3 is 1, plus 4. And that's my GCF. Okay, so we can have a variety. We can have numbers 1 and 2, numbers and variables are GCFs, sometimes just variables, sometimes just numbers. Okay, let's try 5 and 6, and then I'll have you do 7 and 8. So I'm not going to write everything out. I'm just going to think about this. So I've got between 8 and 12. I know a 2 will go into both. The next one that goes into 8 would be 4. Will that go into 12? Yeah. 8 will not go into 12. Okay, so my GCF is going to be 4 for the numbers. So for x's, I have 2 x's here and 3 here. So I can take both of these out and 2 of the 3 out. So that means my greatest common factor is going to be 4x squared. I want to take as much out as I can. So 4x squared. Now I divide. 8 divided by 4 is 2. X to the third divided by x squared is x. Now remember, you're really doing exponent rules here if you want. X to the third divided by x to the second. Remember, we do top exponent minus bottom. So 3 minus 2 is 1. So that's another way to look at it, if that helps. Okay, minus 12 divided by 4 is 3. Oops. 3. And then both of the x's are out in front. So that is my factored answer. Okay, number 6. Okay, between 5 and 10, I can divide a 5 out of both. Okay, so 5 for sure. And then how many d's? There are 3 here and 2 here. So I'm going to take both of these and 2 of the 3. So 5d squared is going to be our GCF. So I'm going to set that up in front of parentheses. Now divide. 5 divided by 5 is just 1. I don't need to write that down. D to the third divided by d squared is d. And then plus 10 divided by 5 is 2, and both of the d's are in front. So recheck. This is going to distribute to be 5d to the third, which is what I want, and this will be 10d squared. So we are good. All right, I want you guys to pause and try 7 and 8, and then come back, and there's one more example I want to go through together. Okay, I went ahead and went back to writing factors out. So I start with the one with the smallest amount. I see a 3. Actually I have a 3 in all of the parts. So GCF so far is going to be 3. How about variables? I've got 5 of them here. So start with the smallest. I'm going to take all 3 of these out. I'm going to take 3 of the 4, and then I'm going to take 3 of the 5. So I'm going to be able to have a GCF of 3x to the third. So I've got 3x to the third, and what I've got left, I divided 3 out, and there are 2 x's I did not circle. So I've got x squared minus 4x plus 5. Okay, and that is my final answer here. Okay, number 8, so GCF. So I see a 6, and I can tell a 6 goes into 12 and 24. So I'm going to look at this. I'm going to say there are 5 here, and I can take 5 out of 7 and 5 out of 13. So my GCF is 6m to the 5th. So I need to now factor 6m to the 5th. So what's left would be just 1, but 13 minus 5 is 8. and then minus 2m to the second minus 4, and all the m's are in front. So there's my factored answer. Okay. All right, so when you're working GCFs, I guess do a method that is needed for you. If you are pretty comfortable with your multiplication facts, you probably don't need to write a whole lot out. If it helps you on the variables, since that's the new thing, you might try that. Okay, let's look at one more example here. This example says that the area in square units of a rectangle is represented by this expression. Okay, so that's our A. If the width in units is 3y, what is the length? So let's draw the rectangle. And I'm going to go ahead, it says what the area is. So the whole rectangle covers this expression. 6y to the third minus 15y squared plus 18y. I know the width is 3y. What's the length? Okay, there are a couple of ways to do this. So I know that the area of a rectangle is length times width. So I could look at this and say, and this, we'll just call this L. If I need the L, then I want to, I can solve this equation for L if I want, or I could go ahead and plug in. So let me go ahead and plug in, and we'll talk about a couple of methods. So the area is this expression. Go ahead and plug in the area. Now I don't know L, but I'm going to multiply by 3y. So I want you to see that I'm never going to know what y is here, okay? But my goal is to get L all by itself. So when I have something times something, I need to undo this multiplication by dividing. So I'm going to come through here and divide both sides by 3y. Okay, and so I want to look at this on the right-hand side. I can do some dividing here. I can take 6 divided by 3, 15 divided by 3, and 18 divided by 3. And then I can divide all of the y's. Because I could separate this out. Like I could write this out 3 ways. I could write 3 fractions. Because if I just sort of have a common denominator here, I'm going to actually change this and put plus negative 15. If I have a common denominator, I'm right back to this step right here. So I'm going to finish up and say that my length is equal to 2y squared minus 5y plus 6. And so I'm going to go ahead and put parentheses units. I don't have a unit defined, but that's how we would write it in more of a generic format. So in a way, I've just divided out the greatest common factor. You could look at it that way. Divide everything by 3y. Okay, so that is our length of our rectangle. Okay, that wraps up day 3, factoring with our GCF.